Welcome back. In the previous lesson, we understand how to display the image. Now, let us understand the simple concept that is color space. Color space is converting the image into one color format into another color format. For example, converting the image RGB to BGR, BGR to RGB. And also we can also convert that RGB image to the grayscale image, which we discussed in the previous lesson. That grayscale image is actually the average of the three matrix, red, green and blue, right? So that's what the idea of the color space, which we are going to discuss in this lesson. Alright, we understand how to read an image, we understand how to display the image. Now let's look into more deeper into the image what we have. Let me consider the OpenCV image img_CV. And if you print the image that is img_CV and we have a very big matrix, right? Let us look into the shape of the image. Dot shape, which will give you the shape of the image. We have the 480 rows, 640 columns and 3. 480 rows is basically defines the height of the image. 640 will defines the width of the image. And 3 which define the channel or RGB or BGR. Alright, so that information you can find in the 3. Since I said there are the 3 information out there, that is RGB or BGR, let's say separately one by one what is R component, what is G component and what is blue component. Okay, for that there are the 2 ways we can split the matrix. One is using the simple numpy slicing, and second one is you can use the CV2.split. First, I will show you how to do the numpy slicing. Okay, numpy slicing. Okay, so let's consider the image img_CV. We can do the numpy slicing. As I said, the first one for the OpenCV image is in the BGR format. Therefore, the first index will be the B and the second index will be the green and third index will be the red. Okay. In order to access those pixels, we can use simple numpy slicing, saying that I want all rows, all columns, and the 0 index will define the blue color here. And similarly, let me take the green, which is img_CV. I want all rows, all columns, and 1. Let me also define the R, which is img_CV. Now just do the same thing, but here the index position will be 2. Okay, now let's execute this, and here you go, we have all the information. Let us display one by one. I'm going to use the OpenCV method to display this. Okay, so let me display this CV2.IMG, and this is my blue channel, and the matrix is blue. And similarly, let me also display the green channel. This is my G, and let me also display the red channel. This is my R. Now let's see the CV2.wait key, set the wait key to 0, and CV2.destroy all windows. Let's execute this, and this is my blue channel, this is my green channel, and this is my red channel. Let me do this. Okay, cool. That's what we have here. So let me also display my original image, which is CV2. Okay, let me close all these things first, and now CV2.IMG, and this is my RGB. Oh, this is my BGR image, and nothing but img_CV. Okay, this is my original image. And what you can notice is that the blue channel basically highlights, means we have the higher values, which are values near to 1, is wherever you have the blue portion in my original image. And similarly, if you look into the red, you can look into this portion of the image, where actually in our original image we have the red color, and that what you can see here. And the rest, and actually you can see in the green color there are some kind of spots, which actually the green color. And also you can see some highlights of the color because this is a mix of blue and green, and this is what we can able to get this. Okay, so the idea of that is different channels will give you the information about the different colors, like blue, green and red. Cool. That's what we can do the splitting using the BGR. The same analysis you can also do it for the RGB image too, that which is matplotlib. Okay, so that's what we can do manually by doing the numpy slicing. We can also split the image using the OpenCV split channels. In order to split the channels with OpenCV, we can use cv2.split and now specify the matrix, so which is nothing but the multi-channel array. The matrix is image_CV. Now this will actually split the image into B. Obviously, since it is a BGR image, so B comes first, followed by green and followed by R. Now that's going to be equal to this. Now let's execute this, and now you can see that B, which is also the same information B, and let me display all the information with the same BGR. Now let's execute this, and obviously you got the same thing. You can use either this, or you can also use either this, which you are getting the same information. Okay, this is how we can split the image into the multiple channels. But once you analyze a single matrix, that is B, if you display this is simple two-dimension array. You can see this is the look in the shape of that. This is simple two-dimension array. The G.shape and R.shape all are having this identical matrix, all are the two-dimension array, whereas our original image, which is the BGR image, is three-dimension image. We have 480 rows, 480 columns, and 3 represents the channel. If you combine all 3, you will get this image. That's the information about the channel. Okay, now by just looking into the idea, what we can do what kind of conversions we want. It's just interchange of colors, right? So OpenCV has a convert color module. Using the convert color module, you can convert our image into any other form we want. Okay, converting color, let's say BGR, converting color. The first I'll do the operation of BGR to RGB. We can simply do the BGR to RGB using cv2.convertColor, and the source image will be my image_CV, which is my BGR image. Now if at all you want to convert that into the RGB, I can use the color codes color_BGR. You can see there are different kinds of formatting we can do. It's not only the BGR to RGB, we can do many things. But anyway, let's see how to do the BGR to RGB. This is my image_CV_RGB. Now let's execute this, and this will be my RGB image. You can display this, use a matplotlib, because we know that matplotlib will display the image in the RGB. So let me display this cv2.rgb. Now plt.axis set to off. Next is plt.show. Here we go. This is what the RGB image. Previously, if you remember, when we display the OpenCV image, which is the BGR, this is what in this format. And when we do the converting of the colors, converting colors is basically just interchange of colors. If you do that, this is what the image what we got.